Unrestricted AI used to sound like a science fiction phrase. Now experts are using it in serious conversations about Tesla's newest humanoid robot, and that's exactly why people are getting nervous. Tesla Bot Gen 3, also known as Optimus, is no longer just a machine following simple commands. Tesla is pushing toward a future where robots can understand environments, adapt in real time, learn tasks faster, and eventually operate with far less human supervision. That's the part experts have warned about for years. Not killer robots or Hollywood-style AI takeovers, but highly capable machines making decisions humans didn't fully predict. Over the last year, Optimus has shown massive improvements in movement, hand control, object handling, and task learning. Tesla is even preparing to deploy these robots inside its own factories before larger production starts. And according to Elon Musk, humanoid robots could eventually become more important to Tesla than cars. That's a huge statement, because once advanced AI leaves the screen and enters the physical world, even small mistakes can suddenly become very real. Tesla may be closer to that moment than most people realize. Tesla is not building Optimus as a side project. Elon Musk has repeatedly said he believes humanoid robots could eventually become more valuable than Tesla's entire car business. That sounds unbelievable at first, until you think about what Tesla is actually trying to build. A machine that can walk into almost any environment designed for humans and immediately start working there. Factories, warehouses, construction sites, stores, and even homes are already designed around human movement. That's why Tesla chose a humanoid design instead of robots with wheels or fixed robotic arms. Instead of redesigning the world for robots, Tesla wants robots that naturally fit into the world we already have. Gen 3 is reportedly a major step toward that goal. Tesla has been developing improved hand systems with far more dexterity, smoother movement, stronger balance, and faster AI processing using newer chips connected to Tesla's expanding AI infrastructure. The company is also training Optimus using techniques similar to full self-driving, where AI systems learn patterns from massive amounts of real-world data instead of relying only on traditional programming. Tesla plans to first deploy Optimus robots inside its own factories before expanding production further. Musk has even claimed Tesla could eventually produce millions of humanoid robots per year if development goes according to plan. That vision is exactly why some experts think the company may be moving too fast. When people hear the phrase unrestricted AI, they often imagine robots suddenly becoming conscious and turning against humans. But that's usually not what experts mean. The real concern is much simpler and much more realistic. Traditional robots follow strict instructions. They repeat the same movement over and over inside controlled environments. If something unexpected happens, they usually stop working properly. Modern AI systems are different. They adapt, learn patterns, and make decisions in situations they were never directly programmed for. That flexibility becomes much more complicated when the AI is controlling a physical machine. Experts in AI safety have warned for years about something called alignment problems. That means an AI system may technically follow a goal while still behaving in ways humans never intended. For example, if a robot is told to complete a task as quickly as possible, how does it balance speed versus safety? How does it understand human intent? What happens if it misunderstands instructions inside a busy environment? These problems already exist in software today, but now imagine them connected to a humanoid robot operating in the real world. That's the issue experts are worried about. Not evil intent or robot consciousness, just unpredictability. Critics worry that companies racing to dominate AI may deploy systems before fully understanding how these behaviors evolve at scale. Most robotics experts are not saying Tesla Bot will suddenly become self-aware and attack humanity. That's the Hollywood version of the story. The real-world risks are smaller, quieter, and honestly much more believable. Imagine a robot misunderstanding an object it's carrying, misjudging distance around workers, moving too quickly in the wrong direction, or learning shortcuts humans never intended it to learn. These are the kinds of problems engineers already deal with in advanced AI systems today. The difference is that physical AI has real-world consequences. If a chatbot gives a bad answer online, it's annoying. If a humanoid robot makes a bad decision while lifting equipment or operating around people, the risks become completely different. Unlike traditional industrial robots that stay locked behind safety barriers, humanoid robots are specifically designed to move around humans directly. That changes everything. Now, the challenge isn't just software reliability, it's physical safety in unpredictable environments filled with people, objects, noise, and constant movement. As robots become more capable, Experts believe the hardest problem won't be building intelligence. It'll be controlling that intelligence consistently in the real world. Part of the concern also comes from how Tesla approaches AI development compared to many other robotics companies. Tesla believes real-world data is the answer. The company used this same philosophy for full self-driving. Instead of relying heavily on expensive sensors like LiDAR, Tesla pushed camera-based vision systems trained on enormous amounts of driving footage. Now it appears to be applying similar ideas to Optimus. The robot watches humans perform tasks, the AI learns patterns, and then it tries to repeat those actions more naturally over time. Some engineers think this strategy is brilliant because real-world learning can scale much faster than manually programming every movement. Others think it's risky because AI systems trained from messy real-world data can also learn unexpected behavior. Tesla also has a long history of aggressive timelines and public beta testing. Supporters argue that's how innovation happens. Critics argue that physical AI may require a much slower and more cautious approach than software products. This is where the debate becomes intense. Tesla isn't acting like a traditional robotics company. It's acting more like a Silicon Valley AI company moving at startup speed, except this time the product has arms and legs. To be fair, a lot of online discussion around Tesla bots still mixes real progress with internet exaggeration, so it's important to separate confirmed demonstrations from speculation. What Tesla has officially shown is still impressive. Recent Optimus demonstrations revealed smoother walking, better balance, object sorting, and significantly improved hand coordination. The robot can now handle delicate items like eggs, fold clothes, and perform repetitive factory-style tasks with much more precision than earlier versions. Tesla also demonstrated Optimus navigating environments more naturally and learning through observation. But there's an important detail many people miss. Some earlier demos relied partly on teleoperation, meaning humans were still assisting or controlling certain actions remotely. Critics argue Tesla sometimes presented capabilities in ways that looked more autonomous than they actually were. At the same time, the improvements are clearly real. The robot's movement today looks dramatically more advanced than it did just 2 years ago, and the speed of improvement is what surprised many people in the robotics industry. There are also rumors about future voice interaction systems and deeper integration with XAI technology like Grok, but as of today, many of those claims remain unconfirmed publicly. That distinction matters because the internet often jumps from advanced prototype to fully autonomous robot worker almost overnight. Reality is usually somewhere in between. The reason conversations around Optimus became more serious recently is because people started imagining what happens when these robots become less task-specific and more general purpose. That's a very important difference. A robot programmed to perform one factory movement is relatively predictable. A robot designed to understand language, adapt to new environments, solve unfamiliar problems, and interact naturally with humans is much harder to control perfectly. That's where terms like unrestricted AI start appearing. Not because Tesla officially announced unsafe robots, but because broader reasoning abilities inside physical machines create entirely new challenges. The rumors surrounding possible future connections between Tesla robotics and XAI systems only added fuel to that discussion. To be clear, there is currently no public evidence that Optimus is operating with fully unrestricted autonomous intelligence. A lot of the more dramatic claims online are speculation, but experts are focused on where the technology is heading, not just where it is today. Once companies begin combining advanced language models, real-world robotics, and long-term autonomous behavior, the systems become far more difficult to predict. And unlike software apps, robots can physically affect the world around them. That's why many researchers believe this decade could become one of the most important turning points in AI history. What makes Tesla different from many robotics companies is scale. Tesla already has massive factories, huge computing infrastructure, advanced AI teams, custom chips, and billions of dollars flowing through its ecosystem. Most competitors don't have all of those advantages at the same time. Companies like Boston Dynamics, Figure AI, and Agility Robotics have impressive robots too. In some areas, they may even appear more advanced today. But Tesla's strength is manufacturing at scale. If the company solves enough of the AI problems, it could potentially mass-produce humanoid robots faster than almost anyone else. That possibility is exactly what gets both investors and experts so focused on Optimus. The moment humanoid robots become affordable and scalable, the entire economy could start changing very quickly. At the same time, Tesla's greatest strength may also be its biggest weakness. The company moves aggressively, and when physical AI is involved, moving fast can create risks that software companies never had to deal with before. If humanoid robots eventually become common, the effects could reach almost every part of society. Some jobs could disappear while others become safer. Factories may run with far fewer workers. Warehouses could become highly automated. Dangerous jobs like mining, heavy lifting, or disaster response might increasingly shift toward robots instead of humans. Supporters argue this could improve productivity and reduce injuries. Critics worry it could also create major economic disruption. Then, there's the bigger question nobody fully knows how to answer yet. What happens when highly capable AI systems become part of daily human life? Imagine robots assisting elderly people, cleaning homes, delivering packages, or working night shifts without breaks. That future sounds useful, but it also raises concerns around privacy, dependence, surveillance, hacking, and human replacement. The reality is that humanoid robots are no longer a distant fantasy. Multiple companies are now racing toward the same goal at the exact same time. And if Tesla succeeds with Optimus at scale, the transition could happen much faster than most governments or industries are prepared for. For years, AI researchers warned that the biggest risks would begin once advanced intelligence entered the physical world. Now that future is starting to look real. Tesla Bot Gen 3 is not a science fiction machine. It's a serious attempt to build scalable humanoid robots powered by increasingly advanced AI systems. That's why the conversation has changed. Not because people are afraid of killer robots, but because humanity may be approaching a moment where machines can learn, adapt, and operate beside us in ways we've never experienced before. And nobody truly knows how fast that future is coming.